SC cable is not permitted for underground installation, regardless of whether it is encased in conduit. The primary reason for this restriction lies in the cable's construction and its inability to withstand the harsh conditions present in underground environments. SC cable, which stands for Service Entrance Cable, is typically designed for above-ground applications, specifically for bringing electrical power from the service drop or service lateral to the main service panel of a building. Its insulation and outer jacket are not formulated to resist prolonged exposure to moisture, chemicals, and the mechanical stresses associated with direct burial or underground conduit systems. Underground environments are inherently damp and can contain a variety of corrosive substances, such as acids, alkalis, and salts, which can degrade the cable's insulation and conductors over time. This degradation can lead to electrical shorts, ground faults, and ultimately, failure of the electrical system. Furthermore, underground cables are subject to mechanical stress from soil movement, rocks, and other debris. SC cable's construction is not robust enough to withstand these stresses, increasing the risk of damage and failure. Conduit, while providing some degree of physical protection, does not eliminate the risk of moisture ingress and chemical exposure. Condensation can form inside the conduit, and water can seep in through joints and fittings, creating a damp environment that is detrimental to SC cable. Additionally, conduit systems may not be completely impervious to corrosive substances in the surrounding soil. In contrast, underground service entrance, or use cable, is specifically designed and manufactured for direct burial or underground installation. Use cable features a robust insulation system that is highly resistant to moisture, chemicals, and abrasion. The insulation is typically made of cross-linked polyethylene, which provides excellent electrical properties and resistance to environmental degradation. Some use cables also have an outer jacket made of a durable material, such as polyethylene or polyvinyl chloride, for added protection against mechanical damage and chemical attack. The National Electrical Code, or NEC, provides detailed requirements for the installation of electrical cables and wiring methods, including specific provisions for underground installations. NEC Section 310.10 C addresses the use of cables in wet locations, stating that cables installed in wet locations shall be identified for use in such locations. This typically requires the cable to be listed and labeled for wet locations or to have an impervious sheath. SC cable typically does not meet these requirements for underground installation. NEC Section 300.5 provides minimum burial depths for underground cables and raceways, depending on the voltage, location, and type of installation. These requirements are intended to protect underground cables from physical damage and ensure safe operation. Use cable is designed to meet these burial depth requirements, while SC cable is not. The use of improper cable types in underground applications can have serious consequences, including electrical hazards, equipment damage, and potential fire risks. It is crucial to select the appropriate cable type for the specific application and to follow all applicable codes and standards to ensure a safe and reliable electrical system. In summary, while encasing SE cable in conduit might seem like a way to protect it underground, it does not provide adequate protection against moisture, chemicals, and mechanical stresses. Use cable is the appropriate choice for underground applications due to its robust construction and resistance to environmental degradation. Always consult the NEC and local electrical codes for specific requirements and guidelines for underground wiring installations. Ignoring these regulations can lead to dangerous situations and costly repairs. The differences between SE and use cable extend beyond their intended applications and involve specific design and construction features that make use cables suitable for direct burial and underground conduit installations. Let's delve deeper into these differences. Firstly, the insulation material used in use cable is specifically formulated to resist moisture absorption. Underground environments are inherently damp, and cables buried directly in the soil or installed in underground conduit systems are constantly exposed to moisture. If the insulation absorbs moisture, its electrical properties can degrade, leading to reduced insulation resistance, increased leakage current, and ultimately, electrical breakdown. Use cable insulation is typically made of cross-linked polyethylene, or XLPE, which has excellent moisture resistance properties. XLPE is a thermosetting polymer that is created by cross-linking polyethylene chains. This cross-linking process enhances the material's mechanical strength, thermal stability, and resistance to chemicals and moisture. Secondly, use cable is designed to withstand direct contact with soil and other potentially corrosive materials. Soil can contain a variety of chemicals, such as acids, alkalis, and salts, which can attack and degrade the insulation and conductors of underground cables. Use cable typically has an outer jacket made of a durable material, such as polyethylene or polyvinyl chloride, or PVC, which provides a barrier against these corrosive substances. This outer jacket protects the insulation and conductors from direct contact with the soil, extending the cable's lifespan and ensuring its reliability. Thirdly, use cable is mechanically stronger than SE cable. Underground cables are subject to mechanical stress from soil movement, rocks, and other debris. Use cable is designed to withstand these stresses without damage to its insulation or conductors. This is achieved through a combination of factors, including the use of thicker insulation, a reinforced outer jacket, and tightly compacted conductors. The increased mechanical strength of use cable ensures that it can withstand the rigors of underground installation and maintain its electrical integrity over time. Fourthly, use cable is often sunlight resistant. While underground cables are not directly exposed to sunlight, they may be exposed to sunlight during installation or if they emerge above ground for short distances. Sunlight can degrade the insulation of some cables, causing them to become brittle and crack. Use cable is often designed with a sunlight-resistant insulation material to prevent this degradation and ensure its long-term reliability. Fifthly, use cable is marked for underground use. To ensure proper installation and prevent the use of inappropriate cable types, use cable is clearly marked as suitable for underground use. This marking typically includes the letters US or USM and S2 printed on the cable's outer jacket. The presence of this marking provides assurance that the cable is designed and tested for underground applications. The National Electrical Code, or NEC, provides specific requirements for the marking of cables and conductors to indicate their intended use and voltage rating. These markings help electricians and inspectors to identify the correct cable type for each application and ensure compliance with safety standards. Sixthly, SE cable is not designed for continuous immersion in water. While use cable is designed to withstand prolonged exposure to moisture, SE cable is not designed for continuous submersion in water. If SE cable is installed in an underground conduit system that is prone to flooding or water accumulation, the cable's insulation can break down, leading to electrical shorts and ground faults. Use cable, on the other hand, is designed to operate reliably even when submerged in water. In addition to these design and construction differences, the installation practices for SE and use cable also differ. SE cable is typically installed in exposed locations or within walls or ceilings, where it is readily accessible for inspection and maintenance. Use cable, on the other hand, is installed underground, where it is not readily accessible. This means that use cable must be installed correctly the first time, as repairs or replacements can be difficult and expensive. When installing use cable, it is important to follow all applicable codes and standards, including the NEC and local electrical codes. This includes ensuring that the cable is buried at the proper depth, protected from physical damage, and properly terminated at both ends. It is also important to use the correct type of connectors and fittings to ensure a watertight and corrosion-resistant connection. In summary, the differences between SE and use cable are significant and relate to their intended applications and the environmental conditions they are designed to withstand. Use cable is specifically designed and manufactured for direct burial and underground conduit installations, while SE cable is intended for above-ground applications. Using SE cable underground, even in conduit, is a violation of the NEC and can lead to serious electrical hazards, equipment damage, and potential fire risks. Always select the appropriate cable type for the specific application and follow all applicable codes and standards to ensure a safe and reliable electrical system. Now let's talk about the different types of use cable. There are primarily two types of use cable recognized by the National Electrical Code, or NEC. These are use and US M-2. The primary difference between them lies in their temperature rating. Use cable has a temperature rating of 75 degrees Celsius, or 167 degrees Fahrenheit in wet and dry locations. US M-2 cable, on the other hand, has a temperature rating of 90 degrees Celsius, or 194 degrees Fahrenheit in dry locations and 75 degrees Celsius, or 167 degrees Fahrenheit in wet locations. This high temperature rating makes US M-2 cable suitable for applications where the cable may be exposed to high ambient temperatures or carry high current loads. Both US and US M-2 cables are suitable for direct burial and underground conduit installations. They are both designed to withstand moisture, chemicals, and mechanical stresses associated with underground environments. However, it is important to select the appropriate cable type based on the specific application requirements, including the ambient temperature, current load, and environmental conditions. In addition to US and US M-2 cables, there are other types of underground cables that may be used in specific applications. These include underground feeder, or UF cable, and medium voltage, or MV cable. UF cable is a type of non-metallic sheet cable that is designed for direct burial and underground applications. It is similar to US cable but has a different construction and is typically used for low-voltage applications such as residential wiring. MV cable is designed for high-voltage applications such as power distribution and transmission. It is typically used in industrial and commercial settings where high-voltage power is required. When selecting an underground cable, it is important to consider the voltage rating, ampacity, temperature rating, and environmental conditions of the application. The cable must be able to safely carry the required current load without overheating or experiencing voltage drop. It must also be able to withstand the environmental conditions of the installation, including moisture, chemicals, and mechanical stresses. In addition to selecting the appropriate cable type, it is also important to follow proper installation practices. This includes ensuring that the cable is buried at the proper depth, protected from physical damage, and properly terminated at both ends. It is also important to use the correct type of connectors and fittings to ensure a watertight and corrosion-resistant connection. The NEC provides detailed requirements for the installation of underground cables and raceways, including minimum burial depths, conductor sizing, and overcurrent protection. These requirements are intended to protect underground cables from physical damage and ensure safe operation. It is crucial to follow these requirements to ensure that the electrical system is installed safely and reliably. In summary, there are several types of underground cables available, each designed for specific applications and environmental conditions. US and US M-2 cables are the most common types of underground cables used for residential and commercial wiring. UF cable is another type of underground cable that is used for low voltage applications. MV cable is used for high voltage applications. When selecting an underground cable, it is important to consider the voltage rating, ampacity, temperature rating, and environmental conditions of the application. It is also important to follow proper installation practices and comply with all applicable codes and standards. Now let's talk about some common mistakes to avoid when installing underground cables. One common mistake is using the wrong type of cable. As we have discussed, SE cable is not designed for underground use and should never be installed underground, even in conduit. Always use US cable, UF cable, or another type of cable that is specifically designed for underground applications. Another common mistake is burying the cable at the wrong depth. The NEC specifies minimum burial depths for underground cables depending on the voltage, location, and type of installation. Burying the cable too shallow can expose it to physical damage from digging or other activities. Burying the cable too deep can make it difficult to locate and repair if necessary. Always follow the NEC requirements for burial depth. A third common mistake is failing to protect the cable from physical damage. Underground cables can be damaged by rocks, roots, and other debris. To protect the cable, it is important to install it in a trench that is free of sharp objects and to backfill the trench with clean soil. You can also use a conduit or other protective covering to shield the cable from physical damage. A fourth common mistake is using the wrong type of connectors and fittings. Underground cables are exposed to moisture and chemicals which can corrode connectors and fittings. It is important to use connectors and fittings that are specifically designed for underground use and are made of corrosion-resistant materials. A fifth common mistake is failing to properly terminate the cable. The ends of underground cables must be properly terminated to prevent moisture from entering the cable and causing corrosion. It is important to use the correct type of termination kit and to follow the manufacturer's instructions carefully. A sixth common mistake is not marking the location of the underground cable. Underground cables can be difficult to locate, especially if they are buried deep. It is important to mark the location of the cable with stakes, flags, or other markers to prevent accidental damage during digging or other activities. A seventh common mistake is not following the NEC and local electrical codes. The NEC and local electrical codes provide detailed requirements for the installation of underground cables and raceways. It is important to follow these requirements to ensure that the electrical system is installed safely and reliably. Failure to comply with these codes can result in electrical hazards, equipment damage, and potential fire risks. In summary, there are several common mistakes to avoid when installing underground cables. These include using the wrong type of cable, burying the cable at the wrong depth, failing to protect the cable from physical damage, using the wrong type of connectors and fittings, failing to properly terminate the cable, not marking the location of the underground cable, and not following the NEC and local electrical codes. By avoiding these mistakes, you can ensure that the electrical system is installed safely and reliably. Finally, let's explore some advanced considerations for underground cable installations. Firstly, consider the soil conditions. The type of soil in which the cable is buried can affect its performance and lifespan. Soil that is highly acidic or alkaline can corrode the cable's insulation and conductors. Soil that is rocky or contains sharp objects can damage the cable's outer jacket. Before installing an underground cable, it is important to assess the soil conditions and take appropriate measures to protect the cable. This may involve using a cable with a more durable outer jacket, installing the cable in a conduit, or treating the soil to neutralize its acidity or alkalinity. Secondly, consider the presence of underground utilities. Before digging, it is important to contact the local utility companies to locate any underground utilities such as gas lines, water lines, and other electrical cables. Digging near underground utilities can be dangerous and can cause damage to the utilities, resulting in service interruptions and potential hazards. Thirdly, consider the drainage. Underground cables should be installed in areas with good drainage to prevent water from accumulating around the cable. Standing water can corrode the cable's insulation and conductors, leading to electrical shorts and ground faults. If the soil is poorly drained, it may be necessary to install a drainage system to remove excess water. Fourthly, consider the thermal environment. Underground cables generate heat as they carry current. The amount of heat generated depends on the current load, the cable size, and the soil thermal resistivity. If the cable is buried in soil with high thermal resistivity, the heat can build up and cause the cable to overheat. Overheating can damage the cable's insulation and reduce its lifespan. To prevent overheating, it is important to select the appropriate cable size for the current load and to ensure that the cable is buried in soil with low thermal resistivity. Fifthly, consider the impact of future construction. Before installing an underground cable, it is important to consider the potential impact of future construction projects. If the area is likely to be excavated in the future, it may be necessary to install the cable in a conduit or to bury it deeper to protect it from damage. It is also important to mark the location of the cable clearly to prevent accidental damage during construction. Sixthly, consider the use of ground fault protection. Ground fault protection is a safety feature that protects against electrical shocks and ground faults. It works by detecting small amounts of current that are leaking to ground and tripping the circuit breaker to de-energize the circuit. Ground fault protection is particularly important for underground circuits, as they are more likely to be exposed to moisture and other conditions that can lead to ground faults. In summary, there are several advanced considerations for underground cable installations. These include considering the soil conditions, the presence of underground utilities, the drainage, the thermal environment, the impact of future construction, and the use of ground fault protection. By considering these factors, you can ensure that the underground cable installation is safe, reliable, and long-lasting.